Welcome to the Internet Report, where we cover what's working and what's breaking on the internet and why. Today, we're going to cover the Facebook outage that happened on Monday, October 4th. I'm joined today by Gustavo Ramos, our principal network engineer who covers network operations for ThousandEyes. So, Gustavo, welcome.
Thank you very much, Angelique. Glad to be here.
Yeah, this is a really interesting one. We actually have a lot to unpack because Facebook published an interesting statement that kind of walked through the events that led up to this outage and kind of the phases that it went through. So I think maybe, we can start with that. I mean, we covered, for those of you who haven't read it, we recommend you go to our blog. We did a write-up on what we saw during the outage. So we wanted to kind of go a little bit into more of a deep dive around their statement, Facebook statement on the outage. So this is Facebook's statement on the outage. So we're going to start first with what they describe as kind of like what initiated the outage, because there was a lot of chatter the other day about the fact that this outage was caused by their name servers or routes to their name servers were effectively withdrawn from the internet. And that's not what Facebook says here. So what was really interesting about this write-up that they did was that they indicated that their network backbone went down before their DNS service was made unavailable on the internet when they withdrew routes. And that was something that we saw in our own tests because, here we are, this is tests that were run between 1540 and 1545, and that's basically, when the issue kind of, they reported the issue to have started. And it wasn't a DNS issue initially. We see basically network errors. We're not getting any response from Facebook. And then, we see within a few minutes, then they all go to DNS errors. And DNS is kind of the tip of the spear, like you're hitting the DNS servers before you're hitting the web app servers. So if DNS is down, you're gonna that's kind of like step one, right? And so step one was failing. But even if it hadn't failed, there was a network issue that would have prevented you from reaching Facebook anyway.
Yeah, and that's interesting to see the data that we have shows exactly what they described. We see that a few seconds or even a few minutes after the network was down, we see the BGP prefixes for their DNS servers being removed from the routing table from multiple points, which is also a clear indication that they use Anycast, and this is public information. We can see that from the task that each Facebook's POP goes down, it removes the prefix from the routing table, and then the routing table needs to reconverge, and it lasted for a few minutes until those prefixes were completely out of the routing table. And that actually led a lot of people to think that this was the root cause. Mm-hmm. But even if you tried to reach Facebook prefixes that were still reachable from the BGP routing table, it was not working. Like if you go directly to those Facebook servers, it wasn't working at all.
Right. And they may have been reachable from a routing standpoint, but from a network standpoint, they weren't. So it was kind of almost, a slightly different problem from the DNS issue. But there was something kind of interesting in terms of how they said this unfolded, because they said, first of all, there was just a single command. They said that somehow took down their entire network. They suggested that the DNS servers getting withdrawn from the internet was by design, right? That it was automatically triggered. It wasn't a misconfiguration. It wasn't what wasn't supposed to happen. They seem to suggest that DNS availability was sort of scaled up and down in relation to server availability. So why would they do that?
Yeah, and that really makes sense, right? Like if they're using Anycast for their authoritative DNS servers, and so they're announcing their prefixes or their subnets from multiple POPs. If a POP cannot properly reach the Facebook's backbone or Facebook servers, that POP stopped announcing that prefix to the internet, right? So removing itself from the internet, which it automatically makes clients to be routed to another POP, and everything is fine if you remove one or two POPs. The problem here is they removed everything at once, right? Or kind of at once, and that took the DNS servers down. From client's perspective, right? Like, so people around the internet was like, oh, my, carriers are failing, like I received server fail, but it was just timing out from the, it couldn't reach the DNS, the other authoritative DNS servers, because they removed themselves because they couldn't reach the servers.
But so there's a couple of things about that I think are interesting. One, that basically it seems like Facebook's architecture is set up in such a way that there's kind of like this centralized dependency. So in other words, in theory, the DNS servers could be operating independently from, the backbone network, right? Connection from the data center. They could, in theory, be responding to queries on their own, right? But there's sort of a design within their service that they need to have this connection to the data, their backbone and be connected to the data centers. So that was one interesting thing. And then the other thing is, it doesn't matter so much from the standpoint of like their customer facing sites, right? Because they wouldn't have been available anyway, right? Like DNS was kind of neither here nor there. But in the statement they put out, they also said that they use their same DNS servers, their same name servers that they use for customer sites for internal systems and tools. And because it was down, they couldn't access those tools, which they needed to in order to resolve, to get the issue fixed quickly, which is really surprising.
That's the second surprise, right? That's the first one is like one command to taking down the global backbone. So this is not like things like that should be rolled out incrementally, right? Like not at once. But okay, that's okay. But even if they go down all at once, you have to have a way to revert it, right? Like an out-of-band network that is reachable, that doesn't depend on anything. There's no circular dependency that eventually can lead to an outage on a very long outage like this one, right?
Yeah. Well, they also you mentioned out-of-band network. It seemed like the control systems for both their production as well as their out-of-band network were effectively the same, because they suggested that both of those were unavailable during this outage.
That is something that's definitely need to be well thought. Like when and how those networks, the production and out-of-band networks are going to touch each other, right? Like you of course you can one can build two networks, right? Two completely separate networks. But at some point they need to touch. You're going to need to reach services for authentication or logging and things like that, right? So this is again very surprising that they didn't have any external tool or anything that it's outside of their out of band or production network that you troubleshoot, you see what is going on, like, and react faster to such an event. Again, a lot of surprises here, coming from such a huge
Right.
network.
Well, the other thing too that we had talked about was, so the role is a lot of sort of industry conversation around, like, okay, redundant DNS and all of that, and some of it is, there's some merit in it, but also there's a lot of complexity too, because one of the reasons why certain providers are just using a single DNS provider is because it's sort of tied into to like their CDN service, right? And the CDN needs to be able to control the DNS records, because that's how they load balance traffic to their infrastructure, and how they optimize connections to clients. It could be that they maybe are directing users to certain servers because they have cached content there that would give them a better experience, right? And so there are definitely reasons why you wouldn't have redundant DNS if you're using it to route users to your application. And in the case of Facebook, they use their own CDN. So it kind of makes sense that they would have just their, one DNS for their customer facing properties. But it's really surprising that that would also apply internally, because you don't have that same constraint for your internal systems. You're not load balancing this for, millions of users around the globe. This is just for your administrators and your employees. So in that instance, it does seem like redundancy would have at least allowed the network operations team access to these tools that they referred to in their statement.
Yeah, for sure. It's like from the outside, we actually don't really know how Facebook built their internal tooling and systems. But from the outside perspective, it seems that everything is in one basket, right? All the eggs are in one basket using the one set of authoritative DNS servers for all, or at least some of the Facebook's public domains, which is not, as you said, well, it's not necessarily for the CDN or traffic routing purposes, right? Like you have your customer-facing application, you have the domain responsible for that, for customer-facing applications, and that needs to go under a CDN infrastructure, right? But everything else, not necessarily, right? Like your tooling, your logging, your monitoring, authentication, everything else you can remove from this basket and just have a little bit of, or remove the circular dependency here, if that was the case with Facebook.
Yeah, it's kind of interesting because we've seen in some recent outages where everything is kind of so centralized. There's, like, to your point, you mentioned circular dependencies, or kind of, so many of the systems are on the same infrastructure or using the same networks, or, I think we saw an instance with one of the cloud providers where one of their services went down, and because one of their other services was using it and it was like a totally unrelated service, that also went down. So it kind of had like this domino effect. And it really kind of comes down to lack of diversity within the service architecture in some ways, whether that's like diversity in terms of like different external services, or, kind of more separation between these different services such that they didn't impact one another if something were to happen.
Yeah, it's interesting for, when we think about Facebook, but it's kind of like we can clearly see that from their statement. But for any any service application out there, right? Like having a clear dependency tree and having proper monitoring for each service like that. Just, you know, having something like that would flag what is wrong, right? Like if you need to monitor each dependency you have for your, you know, delivering your application, you know, at the end of the day, you're going to have to identify those. And if you have things that are not properly designed, you can just fix that ahead of running into issues, right? And that's you know, one thing that when large systems, you know, like hindsight, we can clearly see those, right? And we understand the problems of such large systems to understand all the dependencies and all of that.
Right. But it is sort of interesting that, you know, like if you kind of just think, you know, and maybe this was done, maybe it wasn't, I don't know. But like when you think about, okay, so large, complex service, right? You have this, you know, all these different components, thinking through like what are the failure scenarios? Because I mean, if you have a single sort of management plane for your out of band and your production network, okay, well, what happens when that fails? Like what would happen? And then the scenario where your DNS is sort of scaling in relation to server availability, like, well, what happens if the whole network goes down?
Some of this would be helpful when they are, you know, turning services back online, when they're powering things up. I think they mentioned that in their statement as well. Like it's a concern because everything was down, like not a single thing was up. So they need to be careful when they are bringing this up, right? If we have some, like in an event like that, if you have something that it's still working, or even like a portion of our services that are still working, it's probably easier for you to bring them back online, right? And it's interesting, like I touched on something, like when they started to bring the network up, right? We can clearly see that from our data, right? Like every time they bring a pop-up, the DNS latency goes up because, you know, it's a pop in their Anycast network that comes up, and then everyone is going to, you know, chase that pop. But as they bring more pops, it started to become stable. Latency, the DNS latency started to go down, and you can clearly see that that pattern for them, like bringing each pop online at a time. And it lasts for a couple minutes, for a few minutes. And you can clearly see the availability coming up as well, like when we looked at that curve.
And to your point, it was kind of, you know, it seemed like it started coming up, you know, like fairly rapidly, but then there were a little bit of ebbs in availability. And to your point, because it's anycasted, you know, you spin up one pop and then it's pulling a lot of traffic to it, and that in itself can overwhelm, you know, its servers. You might have packet loss or just servers not available to respond, and then, you know, and then it kind of just continues in cycles as you spin up these services. And then again, even too, as you do that, you might not, like if it was the name server, it may not be able to respond to you. But then because of the way that DNS works, if it doesn't get a response from one of the name servers, it's just going to keep going down the list. And this is actually what happened during the outage, because there was reports that like some of the DNS or DNS resolver providers were basically saying they were getting they had to handle a lot of traffic, because the way that DNS works is there's some inherent resiliency. And so because they weren't getting a response from one of the servers, and they just like went down the list. So what would have just been one query before the outage was like quadrupled during the outage. So that was kind of an interesting thing in terms of like more DNS traffic more queries happening during the outage. And then also just the fact that a lot of service providers didn't have routes to Google's, or excuse me, to Facebook's DNS servers. So there would have been just traffic being dropped in their network. And that wasn't an outage in their network. That was really because of how BGP works, and they just didn't have a route.
Yeah, it's interesting. Like, there's no caching for timeouts, right? Like, there's caching for positive responses from the DNS, so the DNS resolvers can use that cache to provide that same response to multiple or many users. But there's no cache for timeouts and failed responses, so that DNS, the resolvers,
that's a good point.
Need to really ask that again and again. Keep asking until they got a successful response, right?
Right.
That's another. I think it's a concern for network operators, because Facebook's represent a big chunk of the network operators traffic, right? But it also happened. Yes.
Yeah, for sure. So it had kind of a ripple effect through other like ISPs, DNS providers. I think internet exchanges saw like really precipitous drops in traffic at that time as well. And then even when they started to come back online, I think there was some report that CTO had sent out a message to Facebook employees talking about how kind of the network was still kind of getting it back on its feet. And so to kind of just bear with them. And we can kind of see, as, here, like DNS was basically fully restored, right? So the service was back up, and yet we still are seeing issues where the network is still kind of not able to respond. And it did come back pretty quickly after that, so like few rounds where, we're talking like maybe 10, 15 minutes even before kind of the network, and to your point, they were probably slowly bringing up POPs, and then they were getting overwhelmed, and it was kind of, it makes it harder, like you said, to just bring up a service as massive as Facebook's.
We see the BGP announcements. They started a little bit after 2100 or 21 UTC, right? So that's when we see traffic to the DNS servers coming back online, right? Like we see the DNS, the authoritative DNS, coming back online, but only around 22 UTC is when we see some, or at least the point what we were monitoring from Facebook's network started to be available again. In that case, Facebook.com, right? But it took some time to restore everything, and we can clearly see that behavior looking at the DNS tests itself. But then, of course, what it really matters is application availability, right? We wanted to see the page load.
Exactly.
The DNS is just like a...
Right. And I think that's again, like we talk about how critical DNS is, but obviously if what's behind it is not working, then, it doesn't really matter. So it's interesting. There's so many moving parts here. There's just a lot of complexity in terms of delivering applications. DNS has to be working. The announcements to DNS have to be working. Announcements to the web servers themselves have to be working. Those servers have to be working. They have to be connected to whatever backend dependencies that they need to work, because you're typically going to be heading an application's edge, and the application itself is probably behind that. And there's probably a network between them. So there's all these sort of moving parts, and any one of these points of, can be points of breakage, basically. So yeah,
it's really critical, right? For not only for SLA monitoring, but also for respond to such events, right? Like if you don't have visibility into every aspect of your underlying application, like you're probably gonna have a hard time trying to bring it back online if something goes down or goes bad like this. So yeah.
That was basically the outage in a nutshell. We covered off all of the sort of the sequence that Facebook described in terms of the network going down, BGP getting pulled offline, that impacting, or excuse me, BGP announcements to the DNS service getting pulled, and then that impacting their own recovery. So lots of interesting angles to this outage. Again, if you want more details, check out the blog. We'll also be posting this share link that you can interact with and check out yourself. So we hope you enjoyed this unpacking of the outage, and thanks, Gustavo, for joining us. It was really great to have your expertise and inside view from a network operations standpoint. So with that, we will see you at some point in the future. We're being a little bit more reactive with these episodes because it's been a little quiet on the internet. But anytime there's something that's worth discussing, like the incident yesterday, we'll be back to report on it. So be sure to subscribe. With that, have a great week.